Hey folks, it's Paul here from So Real's Astro World. What we're going to do here is I'm going to show you how to produce an animation from the images that are provided by the members of the Big Amateur Telescope group. This is a really cool initiative that's available on the Astro Biscuit Discord server, and I'll provide links at the bottom under the video, and I'll also provide links at the bottom of all the websites you'll need to look at and where to get hold of the data for doing this, and how you can get involved as well. So when you download the files that you're interested in, you'll have something like this. This is the master reference, which is quite important because this is what we'll be aligning all our images to. Although in a lot of cases, the images are already aligned by the users that upload the data. And in this example, there's the HA data that we'll be using for this demonstration. So the question is, why do we need to follow this process? Well, what we're doing here, we've got an image which is the Hubble Variable Nebula, and the idea is to reveal changes inside that nebula as the actual nebula is changing over time. What we don't want to see is the outside changing, and I'll show you an example of what I mean by this. If we load all the files that I previously showed you into our blink process, you'll see there's our blink. And if I run through the blink process on the 16 files that we're working on, you'll see that due to everybody's different seeing, different processing or whatever, where they captured the image of the actual variable nebula, it's all, you're not going to see the changes on the center part because everything else is changing. So what we do is we fix that using the processes I'm going to show you. So the first process that we're going to run is our star alignment. This is assuming that the images that we've got have not been star aligned, but do it anyway, it doesn't take very long. And what we do is we run our files against the master integration file, which is this file here. So we'll open that file. There's our master reference. And then we use our star alignment tool against our images. So choose the view, which will be the master reference for star alignment. Click OK on that. Add in our files, which will be our process files. These ones here. Choose the output directory, which will be reged or regd. Turn off generate drizzle data, don't need that, and we just run the process. As you can see, it doesn't take very long at all. So what we need to do next is to integrate all those files into our master, what I call a master integration file. Just shut down the master reference, don't need that anymore. So we load up the process image integration, just here. Add in all our files from, where was it? It was from the registered folder, wasn't it? Add in all those files. Don't need to worry about any of this, just add those files in. I'm keeping everything as it is. We don't think we need to worry about any of that at the moment. And just run the process. Right, so that's done. So we'll just close that image, we don't need that. And now this has produced this image here, just give that a stretch. This is kind of what you'd be doing if you were making one image of a galaxy or a nebula. But in this case, this is going to be what we will balance all the other images against. So there's that image there. That's the master integration file. I've already got one prepared here, which looks slightly different because it's been stretched and some work done on it. So what we'll do now is we'll just do a little bit of work on this just to turn it into a non-linear image. So I'm just going to run a mask stretch on the integrated file here. We do that by choosing an area of the background as a reference, like that. In fact, I'm just going to move that up out the way of the nebula a little bit. Just there, that'll do, I think. Let's have a look. Yep, that's fine. And then run the mouse over the image and you'll see down the bottom, down in this area, a number. So it says 0027, pretty much all over the image. So we're going to make the upper limit 0035, just put it up just slightly, and then run that stretch on the image. Close down mask stretch and unstretch, and there's your stretched integration file. Remove the preview. And as it's a grayscale file, we can't do anything else really. We can't run color calibration, but what I can do is just reduce the background darkness just a touch. So we need to put a mask on the image. The mask that I'm using here is a pre-prepared mask, but I will show you a bit later on in the video how to actually make this mask. So I have a range mask, which I've just put on the image. And we want to be working on the background, so I need to invert the mask like this, unshow it like that, shut down the mask stretch, and I'm just going to use just a little bit of a curves tweak on it, just to take the background darkness down just a little bit, like that. That's probably going to do. And apply that to the image, shut down the preview, shut down curves transformation, and remove our mask. And that's our master integration file complete. What we use this for is to balance all those other 16 images against, so that the background stays just like this, and all we see changing is the variable nebula in the center. And then in this case, what I do is go to the image, right click on it, go to identifier and change the identifier from integration. You can leave it at that if you want, but change it from integration to HA_master, which is what we'll be using in the pixel math formula, which will be coming up in a bit. Then if you haven't already done so, save your HA_master. And the next part you need to work on is your mask. Now you see that I've already got a mask here created, but I'm going to run through how to create that mask now. It's pretty simple. Take your HA_master file, go to Process, Range Selection, hit the round circle here to give you a preview. See, it's all white. The lower limit box, slide that all the way like this. So it's just, so we're looking at the white area in the center. Don't want to make it too small. Don't want to make it too big. So there is probably good. Under smoothness, move the smoothness slider to the right, like this. Hit the square box to create your mask. Shut down range selection, shut down your preview. And there's your start of a 10 mask. Just got a couple of stars showing here, so what we'll do is we're going to get rid of those. So everything apart from the center part of the range mask is black. So we go to Processes, Clone Stamp, just click on the image. It'll tell you no source point has been defined. So the first thing, change the radius, I don't know, make it to 100. Hold your control key down, click on the image, and now that's using that part of the black image. Go over that white there, go over that white star there. That's pretty much all you need to do. And click the tick box here. Shut down Clone Stamp. Here is your mask. So I'm just going to get rid of this off my screen now. And then we just file, save as, save that range mask. Just call it range mask, like that. And then change the identifier. I think it was range_mask, wasn't it? Let me just check. Yep, just range_mask. And then save that again, save as, range_mask. Take a note of where you're saving the file because you're going to need it in a minute. Process file is HA in my particular situation here. There's your mask created. So the next thing we're going to have to do is to actually crop all these files. Now, this wouldn't be so bad if you were just cropping, say, 1 or 2 files. You could do it, no problem. But if you've got maybe 17, like 16, like we've got here, or perhaps 100, it can get a bit laborious. So if you look at each of these files, you'll see that it needs some cropping. There's some artifacts around the outside edges on these images. You can see most of it is just around the outside edges in this particular case. This may not be the same on every set of images that you tried on, but in this particular case it looks like it's just around the outside edge. So we can either manually go through each of these images and crop them, or we can use an image container, which is what I'm going to show you now. So what we do is load up an image container, and the way we do this is to right click anywhere on the grey screen here, click on image container, click on output directory. So I'm going to choose this from regd, because the last process we did was registered. Create a new folder called, in this case, cropped. Then add in all of our files from the regd folder, which is all of these. Add those in. And then also add in your range mask that you saved earlier to the list in the image container. And then load up dynamic crop. Just there. Open the HA master integration file. And we've already identified that the areas that we want to crop are pretty much around the outside edge. So what I do in a case like this, so we don't have to crop too much, is just use the arrows of the dynamic crop. Just go up a little bit like that. And put the mouse there, click and drag all the way down to the bottom. To say that spot there. And release. Now that's selected an area that we will crop this image by, but we're not doing that yet. What we've got is we've got all these files here in an image container, and what we'll do is apply this crop to all those images. And the way we do that, you've got your dynamic crop box here, which has already been set up with these dimensions. We take the little triangle here and drag it to the bottom of the dynamic crop box and release. Okay, and then the last job, we must do this. We haven't cropped this one yet. We click the green tick on the dynamic crop, and that then applies that crop to that image. So what you've actually done here is cropped all these files to the size that we set on the HA master file. But we actually put a crop on this range mask, but this won't have changed. So if you want to have this range mask back on your screen that's in a usable state, you need to reopen that image and put it back on your screen. So let me just show you what I mean. Shut down the image container. Now, if I now drag that over here, which is how you apply a mask, you'll see you get an error, incompatible mask. That's because this is what's loaded in Pixinsight. Even though it's changed in the save file location, the location from where it's open from hasn't changed. So we just need to reload that image so it's back on our screen. So shut down this range mask, it's not needed now. Double click your screen, and we've got to find where we saved it. It was into cropped, wasn't it? If we scroll down here, there it is there, range mask. So just open that one. Now you'll see that if you drag that over there, the mask works perfectly. This is for later on, if you need to use the mask for anything for your processing. So we just remove the mask there and minimize that back up the top. And what we'll do now is we'll just confirm using a couple of random files that we've actually cropped properly, because sometimes these things can go a bit wrong. So just double click your screen, go to the folder called cropped and just pick on a couple of images, any two will do. And make sure, there's the two images, that these two images match our HA master integration. So what we'll do first is just click these square boxes here to bring the images to the same size, the actual frame of the same size. And then ensure that this, actually we could drop that to 1.6 up here. Just we haven't stretched these yet, remember. So just throw a quick stretch on those and then just drag this image over the top of our master integration, and you should see that all the stars line up like that. You see they all line up. Just do it on the other image here. Just drag it across. As you see, as it gets to the edge, it snaps. You can see that we've cropped and we're still successfully star aligned. So the next job is to run an automatic background extraction process. But this is actually a script. If we look under batch processing, we'll find batch ABEX. Now the interesting thing about this script is it doesn't accept XISF files for input. So we have to first convert the XISF files that we have to FIT files. So we close down this ABEX script first, and then we look under scripts again, batch processing, batch format conversion. And here we add in our XISF files. From our cropped folder. Change the output extension to FIT, and the output directory will be FITs, and click OK. And click no, do you want to perform another format conversion, because we don't need to. So now we have that FITs folder containing FIT files, not XISF files, which we can now run on the ABEX. So we reload the ABEX script under batch processing, batch ABEX, add in the FITs files that we've just created. Output directory is going to be ABEX. Output extension, FIT, it doesn't really matter at this point, we'll leave it as .fit. And click execute. And now that's run the automatic batch background extraction on all of our files. So close that down, we're done with that now. Next one, linear fit. So open the linear fit process up, change this as your reference image to HA underscore master, which is of course this image here that we previously created. Again, image container, add all of our images in from the ABEX directory. Output directory, create a new folder, called it linfit, whatever you like, but that's what I'm going to use. And again, triangle over the bottom of the box. This will then try to match the intensities of all of our images to our master file. Takes a little while, this one. It's not as quick as the other ones, but it's only 16 images, so it shouldn't take that long. There we go, that's done that. So again, reset, close it down, close down linear fit. So our next job is to stretch all of our images, because at the moment they are linear and you won't see anything unless you stretch. As you can see, I've just picked on one of the images here and it's totally black, of course, unless you put on a stretch. So we need to stretch all those images, again using an image container. So load up your image container, add the images from our linfit folder. So all of those images. Output directory, we're going to call MS for mask stretch. Open up the mask stretch process here, and as before, drag the little triangle over the bottom of the box. So now we have all the images stretched into this folder here, which means we can again reset the image container, shut that down, and shut down our mask stretch box. We're done with that. And the next job, and possibly your last job, you'll be glad, is we have to make the backgrounds of the images the same as this background, all the way through the sequence of files that are going to be used in the animation. Otherwise, you're going to have the background flashing at the same time as the nebula, and you won't be able to see the changes. So there's two ways of doing this. You can either run Pixel Math manually, or you can do it using an image container. So I load up our HA Blend Master because we're dealing with HA images, and have a look and see what's going on. And the easiest way to demonstrate what this does is to actually do it. So first image, we've got our HA master, and we've got our range mask, and we'll just add any image from our list here. And what we'll do is we'll just drag this little triangle over this image here, and that creates a new image that looks like that. Now what that has done, it's left the variable nebula intact, but it's replaced the background of this image with the background from this image, from the HA master. So I suggest, if you want to do it this way, just shut that down, We know what it's doing. Put that up there. If you want to do it this way, let's just show you on another image. You change the destination to replace target image. All right, and then just drag that over there, and then it'll change it to, it'll actually change the image because it's going to use the same image but make the changes to that, and then do a file and save it as in the Pixel Math folder. Just save it into there. Alternatively, you can use a image container. So again, we load up an image container, output directory. We will make PM for Pixel Math. Add in our images, which are the images from our stretch that we previously did on all the images. Add those in, like that. And then just drag the triangle over the bottom of the box like this. And that will then apply this Pixel Math equation to all of those images in the image container and save them in the PM folder that we created. Now, I had a few problems with this, getting it to work. It took 2 or 3 attempts, and I think the reason that I had a problem with it was because I left it on create new image. So it may take a little bit of fiddling about, but this is how I did it to create all the images that we now have in our Pixel Math folder, which we'll take a look at now. So let's just load up a few of the images from the PM folder here and see how they look. So there's three images that we have, and as you can see, the background is pretty much evened out now. But the nebula here in the center should not be. This should be the nebula from each of the images that we had, but using the background from our HA master. So there are some things you can do from this point, but assuming you don't want to, you just want to go ahead and create your video or your GIF or whatever you want to do. Go to Script, Batch Processing, Batch Format Conversion. Add in all these files. Change the output extension to JPG. Output directory. Create a folder called JPG. And click OK. Now you've created a folder with JPGs or JPEGs, which you can now turn into a video, which I'm going to show you right now. So what we do in the video creation software that I use, at least, is we get all the files from the JPEG folder, highlight them all, drag them over into here, right click, add them to timeline, and then what I like to do is just the duration will drop down to 1 second, like this. Then we just play the video that we're creating. You can see that the background is perfectly still, and we have the changes in the variable nebula showing up in the center here. Now there may be some other things that you want to do after this, for example sharpening or histogram equalization, something like that, but I think they are going to have to be applied to each of the frames separately. So if you want to continue on from this, what you'll need to do is use the new mask that you created earlier and apply that to each image as you go, and then carry out whatever sharpening or other processes you want to run on each of the images. So that's it on this video, and I hope this has helped some of you guys who want to try and do some of the Hubble Variable Nebula work with some of your processing. Maybe you could do it on other stuff that you've imaged, perhaps asteroids, comets, or even long-term images that you've taken over time of some of the other nebulas out there, so you can see if anything's changing.